We have studied the transaction object as the one that allowed operations through a screen crudely, the procedure as the one that allows performing them through code in batch mode. And now we will study a third option, a bit of this and a bit of that. Thus, in the comparative chart between transaction and update by specific commands in procedures, we had indicated that while the latter only controlled uniqueness, transactions also controlled referential integrity and executed business logic. As we will see, the business component is obtained from the transaction, discarding the screen but keeping its logic. Therefore, it will check referential integrity and uniqueness, as well as trigger rules and events that are not related to the user interface. Like the procedure, it will be handled through procedural code and not via a screen. Let's start by reviewing what we know about the transaction object. In addition to creating the table in the database, it provides a screen that allows the user to manage the data, receiving immediate feedback, even before sending the order to perform the operation. This is commonly known as client-side validation. Let's review this. Suppose that the user who wants to insert a new attraction is filling in a field that refers to another entity, here category ID, and enter the value 8. Then, from the client, the referential integrity check request is sent to the server immediately. If the related record is not found, the server returns an internal code, the exact code is not important, that indicates this, so that the no matching message is immediately displayed to the user on the screen. On the other hand, if the record is found in the reference table, the inferred attribute is sent to the client, so it is immediately displayed to the user on the screen. Museum in this case as the name of the category. This is what we mean when we refer to interactivity and immediate feedback in the transaction. In this case, in the referential integrity check and in the attribute inference based on it. Uniqueness will also be checked immediately. If a unique index has been defined for attraction name, as soon as the user leaves the field, the attraction table will be searched using that index to check whether a record with the same value already exists. If found, an internal code will be returned to indicate this. So the user is shown the message that attraction name already exists. And finally, rules that are not conditioned to events will also be triggered on the client side. For example, if there were an error rule that doesn't allow leaving the name field empty, if the user leaves it empty, when exiting the field, the rule will execute and the error message will be displayed to the user. However, in this comparison table, we were not referring to these controls performed by the transaction interactively, but rather to these same ones and more, since there will also be rules conditioned to events, performed in batch mode on the server after the user clicks on confirm. These are the ones we're really interested in because they relate to the actual CRUD operation. The ones on the client side are solely there to assist the user, yet they are repeated exactly right here. A large part of this is encapsulated by the business component, which, as we've been saying, is detached from the screen and its interactivity. Thus, we can think of this component as a part of the transaction, specifically the part that corresponds to the CRUD and business logic executed on the server with no relation to the screen, leaving out the commit, which won't be within the BC. If we follow closely again what the transaction does when the user clicks on confirm, it will be easy to understand the business component. We know that once the user clicks on confirm, all the data entered by the user on the screen is sent to the server. We can think of the screen data as being internally stored in an STT variable, which is what gets sent to the server, loaded with the values corresponding to base table attributes. The part of the transaction that executes on the server receives that information. We can think of it as an identical SDT which logically disregards the members that correspond to inferred fields. Then, in batch mode and in the same order in which everything was triggered on the client, it starts performing validations, which include uniqueness and referential integrity and triggering rules. If there are no errors, no rule issues, data type issues, referential integrity issues, or duplicates, once it finishes processing the last field, all the information will be validated, and the DBMS will be asked to insert the new record in the attraction table. Since the ID is auto-numbered, a record will be inserted with the value for attraction ID that corresponds to the next number after the last one used. So, in the SDT-like variable, the values of all the stored and inferred fields will be loaded. For example, the ID assigned to the attraction for the inserted record, and also the values of the inferred attributes. All this logic is what we will execute with the business component, which is more than just this sort of structured data type. The commit will be excluded, which in the transaction follows the CRUD operation, and of course everything that completes the transaction on the client side. Up to this point, we know that the transaction combines rules and events, internal CRUD logic, which includes uniqueness and referential integrity checks, and commit. From it, we can obtain its business component simply by setting the property of that name in the transaction. This will create a data type with a structure identical to the SDT, named after the transaction. But unlike an SDT, it will include embedded logic, to be used through methods and properties. That logic will correspond to the uniqueness and referential integrity checks, transaction rules and events that are not related to the interface, and CRUD operations, excluding the commit. Since it is a data type, like an SDT, it is possible to define a variable based on it, which will be handled using its methods and properties. So, if in any program, such as a procedure, there is a variable of the attraction business component data type, loaded with this data, either assigned explicitly within the source or by parameter, we can ask it to insert a new attraction into the table using the insert method of the variable. It will execute exactly the same as in the transaction when the user clicks on Confirm to insert what they entered on the screen. In other words, that insert will be translated into the internal encapsulated logic, which corresponds to going through each of the fields, represented here by the members of the business component variable, performing the transaction's validations and rule triggers, those that are not related to the interface. This includes referential integrity and candidate key uniqueness checks in our case of attraction name. If there were no errors, the information is considered validated. And, as in the transaction, the insert order is sent to the database, which inserts the record without failing due to uniqueness, since the primary key is auto-numbered. The variable will then contain all current data, including the auto-numbered and inferred values. All of this is silently encapsulated in the insert method of the business component. The transaction also implicitly included the code to perform the commit if the CRUD operation was successful. This logic is excluded from the business component, so if needed, it must be implemented explicitly. Thus, the insert method returns a Boolean value, true if it was successful and false otherwise. So we can write this if that triggers the operation and gets the result. If the operation succeeds, it returns true, and in that case, we explicitly make the commit. That is, the code to insert this new attraction will look like this. With this in mind, isn't the difference between insert with business component and insert using a command crystal clear now? Considering that the insert silently executes all this transaction logic. Here, it will check referential integrity, uniqueness, and trigger rules, whereas here it will only check uniqueness. As for the commit, the same applies. In both cases, since the code is in a procedure, whenever the procedure detects that it performs a CRUD operation, a commit will automatically be added at the end of the source. However, the developer can always add another one wherever they want. What matters for the business component is to clearly understand that the encapsulated logic of the transaction, it will not include the commit. This is precisely to give the developer the freedom to execute it or not depending on their needs. To make this introduction clear, let's implement this example in GNexus. Let's create a procedure. Attraction insert. And define a variable named attraction. We see that among the available data types, we're offered all of them, basic, extended, SDTs. And here we can see those of the business component type. We can also apply a filter here to show us only those types. What we can see here is that at this point we have only these defined in the KB. Attraction is not included. Let's look at this one. Category. If we edit the properties of the category transaction, we see that business component is set to true. This is because it was created by Nexa, which enabled the property by default. We need the business component of the attraction transaction to be created. So we will to enable the property. When we save, the data type with the encapsulated logic will be created. Now, if we open the combo box for the data type and filter those of type business component, we find it there. So, we have now defined this variable of attraction business component data type. Now, in the procedure source, we type the variable AN. And after typing the period, we see the transaction attributes displayed as properties using the same syntax as an SDT. We can also see all these methods, particularly the insert method. Let's assign a value to the attraction name member, for example, this one. Then to the attraction photo, using the image available in the KB. And to the other members corresponding to attributes from the base table itself. Now we have all the values for the attraction we want to insert. So we simply apply the insert method to the variable, which, as shown, returns a Boolean value. That's why we use the if command. If the operation is successful, a commit is executed. To test this, let's invoke this procedure from the web panel we previously created to emulate the work with. When the insert button is pressed, instead of calling this web panel that requested data from the user and then perform the insert, let's call our procedure, which will attempt the insertion using the BC. Let's run it. There was already an attraction with the same name, so when the procedure is invoked, it will do nothing. This is because uniqueness was enforced. If we now delete the attraction and call the procedure again, then it will be created. To avoid a uniqueness error, let's change the name to one that doesn't already exist. And let's trigger a referential integrity failure, for example, by setting the category ID to 20, which we know doesn't exist. Let's try again. Nothing happens. That's because the insert failed due to referential integrity. Remember that when we tried this using the new command, the program would crash. Now, let's leave the attraction name field empty, remembering that the transaction triggers an error in this case. And let's set the existing category to 2, again, so that referential integrity doesn't fail. it wasn't inserted either. As we will show in the next video, another great advantage of updating via business component is that it doesn't have to be done exclusively in a procedure object, as is the case with command-based updates. We could, for example, perform it in an event of a web panel. Also, it's not mandatory to place the insert method within a command that uses its result, such as this if. We could place it alone and even check the result with another method, success, or its opposite, fail. In this video, we focused on introducing the topic, which is why we only analyze the insertion and in the simplest way. In the next one, we'll cover the methods required to perform the other two CRUD operations and how to obtain the messages generated from all of them.